So if you remember from last time, what we talked about was variance and standard deviation. And these are basically the measures of tendency, all right, and the measures of the variability of the equations and of the data, I should say. And we had three types of data. We had raw data, we had sample, and we had population. Okay, so we had these three types of data that sorry, not sample and population. We had raw data. We had sample and population is a part of it, but we also had the single value, I should say, and we had grouped or class. If you remember, we had these three types of data and we had equations or different ways of solving for each one when it came to the mean, when it came to variance, mode before. So just a reminder, raw data is when you have a table, all right, and you just have data points here directly, all right, so like 1, 2, 5, 7. And this is raw data. Single value is when you have a table, so this is basically just the data itself, all right. Single value is when you had one value over here, like let's say 1, 5, 6, 3. This is your data point. And this is your frequency. So how many times it is occurring. Let's say like 1 is occurring 5 times, 5 is occurring 10 times, 3, 2. So you have a single point of data and it's occurring over and over, depending on the frequency. And then we have the grouped class data, which we had data again, and the frequency. All right. And here we had a range for the data. So let's say from 0 to 5, and then from 5 to 20, and then 20 to 60, for example. And then you had the frequency for it as well. All right. So these were the three types of data that we looked at, and we had equations for each. If you remember, the last thing we did was variance and standard deviation. So variance is equal to sigma x squared, or sigma squared, I should say. This is the notation for it, which is equal to different values depending on whether, different equations, I should say, depending on whether it's raw data or single value or grouped data. Okay, I'm not going to go through all the equations right now, but I just want you to remember that standard deviation is simply the square root of variance, if you remember, or just simply sigma. Okay. And like I said, we had equations for all. When it came, the basic equation for variance was sigma squared is, this is for raw data, the basic equation was x minus mu divided by squared divided by n. All right. This was for population. And the other equation for it was the basic one, at least for raw data. It was x minus, again, mu, but sometimes they call it x bar when it comes to the sample. It's the same thing over n minus 1. All right. The reason I'm showing you this again, this is for sample data. The reason I'm showing you this again is I just want to remind you that the only difference between the population is you're just going to have n for population, and this will be determined in the question, whether you're calculating the variance or standard deviation for the population. You're going to have n. And if it's for the sample data, it's the exact same equation, but the only difference is you're going to have n minus 1 at the bottom. All right. This is the same thing for all the cases. This is obviously for raw data, but you remember we did all the different equations. The only difference being n minus 1 is going to be for sample data and n for the population. So now, this was when we had a single data point. So for example, we just had an x value over here. So when we had the table, and we have a table, we would only have the data for one. For example, the x over here, and frequency, like that. But what if we did not have just one data? Like this was, for example, let's say height. What if we had another data point, Yani? What if we had like weight? So we had two different data points. So now we have X and Y data. So if we want to calculate the variance for each, we can easily do that if we're looking at one singular data at a specific point. But what if we wanted to compare both together? This is where you wouldn't calculate variance, you would calculate something called covariance. Covariance basically sometimes written as this, COVXY. All right. This is when you're comparing two different data points with each other. In this case, X and Y, the height with weight. So we are trying to find out the relationship between the height and the weight, and if there even is one uh, in general. All right. And there are different multiple ways of finding covariance. It isn't that complicated. It is almost the same application that we did for variance, but the only difference here is we're going to be doing it for two sets of data, and we're going to be doing it in comparison with each other. We're only going to be looking over raw data. We're not going to be looking over frequencies. Like we're not going to be looking for single value or grouped class. The only cases that I have seen is raw data. So that's what we will be covering. All right. So let's say we have values for X and Y, like for the height, let's say we have 100, uh, let's be more realistic, like 150, 165, 160, 180, for example. All right. Let's say these are the heights of people that we found, and let's say these are the weights for said people. Let's say it was 60, 80, 100, 90, something like that. Okay. So what if we wanted to find now the covariance, or in other words, the relationship between the height and the weight for these data points? So the first thing you're going to do is you're going to find your n. All right, you're going to find your n. What is your n equal to? We have 1, 2, 3, 4 data points. So our n is 4. Okay, and let's say I am trying to find the sample covariance. Okay, remember the difference only between sample and population is when you're trying to find this very standard deviation covariance, whichever equation, you're going to be putting n for population and n minus 1 for sample. All right. Now, let's say we want to find the covariance. The equation for covariance, so covariance, cov x, y, it has many different forms, but the preferred form I like to use is, or sometimes you'll see this as sigma x, y as well. Okay, this is just notation for covariance. The easiest one, in my opinion, as it will simplify all the calculations later on as well when we look at correlation and regression, is sigma, meaning the sum. Remember, when you just see the symbol, in any case, this just basically means adding, right? So we're going to be adding values. The sum of x minus x bar times y minus y bar. All right, that's your numerator. And in the denominator, you're going to have n minus 1, because in this case, we're talking about sample. If we had population, this would be n. So this is for sample, okay, for sample data. If we had population, so if population, population, this would be n. All right, that's the only difference. So if we had the population, it would be that. So if you see, it is a very simple equation. What do we have here? We have our x value, which we already have over here. Then we have our x bar. This is just average. If you remember, x bar is basically sigma x, as in all the values of x, divided by n. And we have here y bar, which is also average or the mean. It's the same thing, which is y bar is equal to sigma y over n. Okay? So the very first step when you have such such a equation over, or such a table, or such a data points. Let me just copy paste this down here. So the first thing you're gonna do is obviously you're gonna be creating a table, but before even that, first thing you're gonna do is find out the value of n. So here we found the value of n is equal to 4. All right, that is the first step. Then you are going to find your sigma x and sigma y so that we can find our averages. All right, so sigma x and sigma y is simply just adding all these values. If I add all these values, it's 150 plus 165 plus 160 plus 180. We get 655. Our sigma y is 60 plus 80 plus 100 plus 90, which is 330. All right, the average, or x bar, all right, again, all I'm doing is applying this equation. X bar is equal to sigma x over n, which is, in this case, 655 divided by 4. 655 divided by 4, that is 163.75. So we found our first point, our first average, I should say. Same thing we're going to do for y. Y bar is equal to, again, y bar is simply just average. So it's sigma y over n, which is 60 plus, we calculated sigma y, which is 330 over 4. 330 divided by 4, that gives us 82.5. Okay? So this is our first step. So we are going to find our x bar and our y bar. Why? Because if you notice here in the equation, we're going to have to find x minus x bar and y minus y bar. All right? So we have done that. Now we can create our table. Okay? So let us just do it this way for now. And then here we're going to find the sum. So the first thing we need to find is x minus x bar. That is the first thing you're going to try to find. Then we're going to find y minus y bar. Okay. And then we are going to find the last thing, which is the multiplication of both, because here we want to multiply both. All right. So it's going to be x minus x bar times y minus y bar. And that's what we are going to do. So we're going to subtract this value, or x 150 point, from our x bar for the first one. So we're going to do 150 minus x bar, which is 163.75. All right, which is equal to 150 minus 163.75. It is going to be negative 13.75. And we're going to do the same for the rest. So the next one is going to be 165 minus 163.75, which is equal to 165 minus 163.75. It is 1.25. And we're going to do the same for the last two as well. We are subtracting this value, or I should say this value, from this value. Okay, so 160 minus 163.75 is going to be negative 3.75, and then 180 minus 163.75 is 16.25. Okay, so again, these are the values that we got, so that there's no confusion. Remember, you need to keep the sign as well inside. Do not forget, if it's negative, you have to keep it as negative. And if it's positive, you keep it as positive. And now we're going to do the exact same thing again for y. So y, in this case, is 60 for the first one, minus the average, which is 82.5. That is going to give us negative 22.5. And we're going to do the same for the next one, which is 80 minus 82.5, which is minus 2.5. 100 minus 82.5, which is 17.5. 82.5, which is 7.5. All right. So again, so that there's no confusion, these are the values that we got. All right. Now, what are we going to do here? The last step is we are going to multiply this value with this value to get minus 13.75 times minus 22.5, which is equal to, I'd rather actually put it this way so there's no confusion. So we are multiplying our x minus x bar value with our y minus y bar. And remember, the signs should also stay, all right? So minus 13.75 minus 22.5 is going to give us 309.375 for the first one. Again, we're going to be doing the exact same thing for the second two values. So 1.25 times negative 2.5. 1.25 times negative 2.5 is going to be minus 3.125. All right. Again, same thing. We're going to be multiplying this value over here with this value. It's going to be negative 3.75 times 17.5, which is negative 65.625. And the last one is 16.25 times 7.5, which is 121.875. All right. And now we are going to find the sum of all of this. So we're basically adding all these values together because this is what the equation wants. We are adding. Remember, when we have the summation, this basically means we are adding. We are going to just add all the values that we found. So 309.375. Remember the signs, all right? This is negative, okay? Remember signs. Do not remove the signs. Do not just start adding without the signs. So plus and minus becomes minus 3.125, minus 65.625, plus 121.875. It's going to give us 362.5. And now we can simply find our covariance because our equation, this equation over here, we have found the value here for the numerator. So again, if I just copy paste this down here. So for covariance, this is going to be equal to, this is the value of all of this, all right? So this value over here is this value that we have found, okay? This is this value. So we're going to put it in this place. It's going to be 362.5 over n minus 1. We have found our n from earlier, which is 4. 4 minus 1. So simply, our covariance is equal to 362.5 divided by 3, which is 120.833. Okay? This basically describes the relationship between x and y, like how close the values are to each other's averages, all right? So before, when we were calculating variance for one value, we were finding out how much it varies or how variable the value is compared to its own average. In this case, we are comparing this with its average, and we are also comparing it with this compared to its own average to see how off the values are from each other. So if we want to draw this, all right, let me just take the values over here. So if we have a graph, this is our x values, and this is our y values. The x values, let's say this is 150 over here, 160 is over here, 165 is somewhere here, and then 180 is over here, okay? Again, these values are, I should say this graph is not up to scale, so keep that in mind, but I'll try to do with what I have. So 60, let's say it's over here. Let's say 80 is over here, 90 is over here, and 100 is over here. So 60, 80, 90, and 100. So if we want to plot the points now, so at 150 we had 60, so it's somewhere around here. At 165 we had 80, so it's somewhere around here. At 160 we had 100, so it will be somewhere around here. And at 90 or at 180 we had 90, so let's say it's somewhere around here. Okay, so we are basically trying to see for a line that is almost going through everything and seeing how much variation there is of this line. All right, this is kind of the idea of covariance. We are trying to relate all these points to this line. If you notice here, the line is going upwards, or I should say the slope is positive. That is why covariance here is positive. So this is what it basically means. It means that as x goes up, y goes up. All right? So this is what this positive value means. All right? If we got covariance as negative, all right, let's say covariance of xy is equal to -5, for example. Okay? For example, for a different data, for a different data set. If we draw the table or the graph xy, I am not sure of where the points are, but I know it is going to be something like this for the slope. Why? Because this is a negative slope, because we have a negative value here, meaning as x increases, as the value of x is going up, and the value of y is going down. This is what is meant by a negative covariance or a negative slope, basically. Okay. And this is basically it for covariance. You're just going to be applying this equation. You're always going to be applying the same table. Just a quick recap. We are going to find the x average. Then we are going to find our y average, or our mean x and mean y, by summing up all the values for the data from the table, and then dividing by the total number of variables in the table. Then we are going to be subtracting x bar from x. Okay, so we're going to be subtracting each and every value here and putting them in the table. Same thing for y. Then we are going to be multiplying them with each other. Once we multiply them, we're going to sum them, and we make sure that we are always remembering our signs everywhere. Once we sum them up, we are just going to plug it in back into our covariance equation and then divide by n-1 for sample. And if we have population, we will only divide by n. All right. Any questions about covariance before moving on? I feel like it's pretty clear. All right. Let's look at, we're going to solve more problems later on, but I want to finish all the concepts first before moving on because they're all related to each other. So this was finding the variability or the covariance between two data points or data sets. Let's look at something else known as linear correlation, which I already kind of touched upon in these graphs. So linear correlation. Correlation, all right. So relation means, basically a relation between one thing and another. Correlation means the relationship that is existing between two things at the same time. Or in statistics, correlation basically means the measure or the amount of relation, you could say, or relatability between two different variables or two different data sets, for example, here, X and Y. So linear correlation, linear meaning straight line, basically, all right? So direct relationship. This is going to describe how the values, when we have a graph, right? This is describing, so let's say we have X and Y, and let's say we have points over here, something like this. All right, so we can notice that we have a positive correlation here because of the slope of this line. It is going up. So this is basically a positive correlation. All right, and because it's a straight line, this is where the linear comes from. It's a linear positive correlation. So we are basically trying to relate how these data points are acting in relative to each other, or in relation 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 to with a line in between, and we need to know how close these data points are to this line, which is known as the line of regression, which we will talk about in a bit. But the idea here is we just need to know how scattered basically these values are. Scattered معناتها متوزعين. ايش كثر التوزيعة على هالبوينتس مقارنة للخط اللي بينهم. تمام؟ So this, as I said, is a positive linear correlation. But let's say we have something like this. Points over here, a lot of data points. But if you notice now, all right, if we want to try to draw a line between all these scattered points, it is going to be downwards, or it's going from y to x instead of from 0 to up, all right? This basically means this is a negative correlation because we have a negative slope, all right? Slope is negative. In this case, our slope was positive. So we had the positive correlation. In other words, all this means is as x increases, يعني كل ما الفاليو مال x increased, went up, became higher. If you notice, يعني here when we are going up, the values for y are also going up. تمام؟ يعني هني the value for y is increasing as the value for x increases. This is what is meant by a positive slope. هني the opposite is happening. So a value for x here is going to give us a value for y here تقريبا. All right? A value of x here is going to give us this value for y. But then when x is increasing, so let's say to here, the value of y is decreasing. It is going down. All right? Here, when x was increasing, it went up. This is the basic idea of negative and positive slopes. So as x is going up, y is going down. All right? So this is what linear correlation is. But let's say we have a set of data points. How do we know how far this point, for example, or all of these points are actually from this line? This is known as the correlation coefficient. All right, so it's called as the correlation coefficient. And it's either sometimes given as R or sometimes as the Greek letter rho. All right, what does this coefficient say? This coefficient basically describes how far these points, these values over here, are from this straight line. All right, and the values of R or rho is always going to be between 0 and 1. All right, and this is basically it. And it also can be equal to 1, and it can be equal to 0 as well. So you get a better understanding of what this R value is. Obviously, this is for a positive slope. Okay. For a negative slope, the values of R is going to be 0 is, I should put it the other way around. So it should be less than or equal to negative 1 R less than equal to 0 because the value is negative for R when the slope is negative. All right. Don't worry, I'm going to explain what that means in a bit. But let us look at what is meant by this R value. Let's get a better understanding of this R value. So let's say for a positive slope. Okay. Let's just compare positive slopes. So let's say we have this positive slope over here. And the values are something like this. So we have the points very close to the line, right? This basically means our R value is very big, or like we could say something around 0.9, for example. All right. So it's a very strong correlation between X and Y. All right. So this is our Y and this is our X. Why? Because if you notice here, the values are, or the points are very close to the line. But let's say we have a different slope and we have points like this. Okay. There still is a correlation. They are increasing together, all right? but the scatter is a bit more. So our R value is going to be a bit less, smaller. So something around like 0.5. Okay. So it has a good correlation, or you could say a moderate correlation. Um, because we have a decent value for R, it is not close to zero. لأن the scatter is not that much that it is almost unseen. So this is what the value of R represents, يعني الcorrelation. This is why it's always from 0 to 1. For R equal 1, all right, if we have R equal 1, and let's say we draw one more over here, okay? If we had R, sorry, 1 minute, let me actually draw these. This is what R will be equal to 1 will look like. R equal 1. So the points are exactly on the line. This is what is meant by R is equal to 1. Okay? Let's look at the negative slope. The negative slope, the only difference is that the line is going downwards. All right? That's all that it means. So here, let's say the points are scattered very close along the line, something like this. Okay. Again, here, R value is going to be, instead of positive now, it's going to be negative 0.9. That's the only difference. And let's say if we have another line where the points are scattered a bit more, so something like this. Okay. These are your data points. These are your values, by the way. These are your values. Yani these 2 points over here are similar to what we plotted. You see here, we only had 4 different values. But here I'm assuming like a lot of different values have been given. All right. So here, our R will be something like negative 0.5. Very close to, it's in between. It's scattered, but it's not too much scattered that you cannot read the graph. So it has a moderate correlation. So usually this is what they call negative correlation. And this would be called a positive correlation. All right. And if you want to look what would be the perfect negative one, again, it's the same exact idea, but we have a downward slope. The points are all going to be exactly, not a single point will be off the line. All the points have to be on the line. Here you have R is equal to -1. And let's say the last point where we have a table, or a graph, I should say, where the points are just scattered, all right? Let me make it a bit better, actually. So we have the points that are just scattered. So we have a point here, a point here, a point here, a point here, a point, something like this. So you don't have any actual line that you can draw, all right? In other words, you basically have no slope, and you would draw a straight line in the middle because you do not have a slope. You do not know exactly what it is. Here, this slope is 0, by the way. Slope 0. Because you do not have any specific place you can draw. This is where you have your R. R here is equal to, or very close to 0. But most of the time, it is going to be close to 0. This basically means that there is no correlation between X and Y. Okay? So again, it's all R does, which is the correlation coefficient, all it does is it measures how much scatter is from a line of regression, or this or the line that you could draw in between them. يعني بس قاعد يشوف لكم التوزيع, how big it is, how much different the points are from each other and from the line, and it gives you a value. So this is what the coefficient, correlation coefficient is. However, how can we calculate this from a data set point? يعني let's say we have a set point. Let's look at the example we did earlier. All right. So let's look at this example where we have already calculated the covariance. Okay. So there are 2 different ways you can find the correlation coefficient. There is one by trying to get it directly, right, from the, يعني if the question directly asks for the correlation coefficient, you can use two equations. So there's the first one which is R. Second. Sorry about that. So again, we have two equations that we can use for correlation. Okay. The first one being, if you do not have the covariance already, all right, you can find it using R is equal to the square root or the summation of x minus x bar times y, or x minus y bar, all right, all over the square root of the summation of x minus x bar squared times the summation of y minus y bar squared. So what you're going to be doing is you're going to be doing the exact same table. The only difference here is you have x minus y bar, so that's going to be one of your columns, and then you're going to have to do x minus x bar squared and y minus y bar squared and have two extra columns. It seems long and tedious, but you can do it this way. But me, I would recommend that you find it using the method you usually find for covariance. يعني I would say when you're drawing the table, it depends honestly on the question, on what it requires, but it's easier to remember always one method. So this is one specific method, but for me, since we already found the covariance of xy here, all right, this is equal to, what value did we get for the covariance earlier? Covariance was 120.833, okay, 120.833. Since we already found the covariance, I like to usually use this equation. Again, this depends on each one. R is equal to the covariance divided by the standard deviation of x and the standard deviation of y. All right. And just a reminder, the standard deviation formula is square root of this is all square root, I think. Yeah. So square root of x minus x bar over n minus 1 in the case of sample, or n in the case of population. Okay? Squared. Yes. And sigma y, it's the same exact equation. It's just the equation of standard deviation that we used before. All right? And the square root comes from, because this is the inside part is the variance. And and if we want to find standard deviation from variance, we just take the square root. So this is going to be y minus y bar squared over n minus 1. Okay? This is what it basically is. This is how you would find the correlation for such an equation. Just 1 minute. I'm sorry, just 1 minute. I'll be back. All right. So again, just a quick recap. So the idea here is we are trying to find the correlation, okay? the R value, basically. This R value we want to know. And we know that our R value has to be between 0 and 1, or between -1 and 0 for a negative slope. And we're going to use the covariance, all right, to find out our R value. If we did not already find the covariance, you can apply using this equation instead, but I do not recommend it. Okay. The reason why I'm saying this is because it is easier to follow a specific sequence عشان تحصلون الكوفارينس وتتعودون عليه، وبعدين تعرفون كيف تحصلون الكوفارينس. It will be very easy to find your R. It will be very easy to find your sigma X, sigma Y. لأن if you notice here, sigma X and sigma Y, this is just standard deviation. Just a reminder. This is standard deviation. Okay. All you need, of course, there's a summation point here. This is sigma. So sum of this and the sum of this, okay? And all you're going to need to do is just find x minus x bar squared and y minus y bar squared. So you're going to be adding 2 extra points over here. And that's all you're going to have to do, and they're very easy. It's not a new calculation. All you're going to have to do is just take the values. So what you're going to be doing is you're going to have x minus x bar squared, and then y minus y bar squared. Okay. So that's all you're going to be doing. So you're going to be taking this value over here. So this value over here, for example, let me keep the highlight. This value over here, you're going to be taking it and squaring it. So it's 13.75 squared. Same thing for the next one, which is 1.25 squared. Next one is minus 3.75 squared. And last one is 16.25 squared. Again, you're going to be doing the same for the y minus y bar. So it's minus 22.5 squared, minus 2.5 squared, 17.5 squared, and 7.5 squared. All right. So you're just taking these values over here and you are squaring them. And once you square them, you're going to find the summation of them all. So you're going to be adding all of them. So let's do that. So we have 13.75 or negative 13.75 squared plus 1.25 squared plus negative 3.75 squared plus 16.25 squared, which is 468.75. Okay, for the first one, when you add them all up. So the second one is going to be for y, negative 22.5 squared plus negative 2.5 squared plus 17.5 squared plus 7.5 squared, which is 875. Okay, one very important point here. This isn't statistics, this is just on usage of the calculator. So make sure when you are writing this value, you write it the exact same way I wrote it here in the calculator, because this is all is going to become a positive value. So when you are squaring, you're also squaring the minus sign. Okay, so always keep your parentheses. What do I mean by that? يعني إذا عندكم negative 13. Okay, if you want to square it, يعني تبون تبون تحطوها في الكالكوليتر، تبون تربيع لا تخلونه بس كذي. Do not do this, okay? So do not do minus 13 squared, لأن this will give you a negative number. Do not do this, all right? What you should be doing is minus 13 in brackets, all squared. So this is going to give you a positive number. And this is the correct way. Tamam? So just make sure of this. This is just a small point, okay? When it comes to the usage of the calculator, it has nothing to do with the actual statistics. Just make sure you do not make this mistake. So once you add up all these values, you get the sum. Once you find and add up all these values, you get the sum. You can now find your sigma x and sigma y. All right. So our sigma x is going to be equal to the square root of the sum that we just found, which is 468.75, 468.75 divided by n minus 1. Again, this is for sample. Remember, we're just talking about sample. If it was population, it would be just n, right? N minus 1, 468.75. Our n value was 4, so n minus 1 is 3. So just 4 minus 1. We put this into the calculator, 468.75 divided by 3, all under the square root, we get 12.5. So this is our sigma x. We will do the same thing for sigma y. It is equal to the square root of sigma y was 875 divided by 4 minus 1, which is square root of 875 over 4 minus 1. It is going to be 17.08. And now we can simply find our correlation coefficient. Now we have our covariance that we found from earlier. Okay, so we have our covariance. This is going to go in the numerator. We have found our sigma x, and we have found our sigma y, which is this value. So our R is going to be equal to our covariance, which is 120.833. So 120.833 divided by 12.5 times 17.08. So 12.5 times 17.08. All right. And then we can find our linear or our correlation coefficient, which is going to be 120 something. 1 second. 120.833 divided by that. It's going to be 0.566. Okay. So this is the value that we got, 0.566. If you remember the graph, if I can bring it back down here, this was the graph that we had. So this was the graph that we had earlier. So if you notice, the points are somewhat close to the line, but are a little bit scattered as well. But there is some sort of increasing value for it. All right. So that's why we have a correlation of 0.566. Yani it's moderate. It's not exactly very close to the line. It's not very accurate because we have this variable going far off. But it is very close. There is a regression of some sort that is going upwards. That is why it is moderately correlating. All right. So it's very straightforward. Again, all you're gonna have to do is if you have found your covariance, you're gonna just plug in the number of covariance in your numerator, and the denominator is just gonna be your standard deviation. And to find that, you're just gonna be adding 2 more columns where you are squaring the values for the first 2 columns that we did. All right, and then when you sum them up, you can find your standard deviation very straightforward. But plug them into this equation in the denominator, multiply them, and you're gonna get a value. Note R has to be less than R has to be less than or equal to 1. So why do I say that? Or I should say R has to be between for a positive slope, okay, for now. And R has to be greater than or equal to minus 1 for a negative slope, okay? And in other words, between minus 1 and 1 for any type of slope. Why am I saying this؟ لأن إذا جوابكم هني طلع أكثر من 1 in the positive area or less than 1 in the negative area معناته جوابكم غلط. معناته this is you did something wrong in your calculation, because this will always result in a number between 0 and 1 for a positive slope, or negative 1 and 0 for a negative slope. Always, all right? So make sure that this value is always going to be between 0 and 1. If you get 2 or 3 or 7.5 or whatever, any number larger than 1, know that you have done a mistake in your calculations. Okay? And this is basically it for correlation. One last point I want to go over is linear regression. So if we were talking about linear correlation, so we're talking about a straight line. So remember, linear basically means a straight line when it comes to graphing. And I know that all of you know the equation of a straight line is y is equal to mx plus b, all right? Where m is the slope and b is the y-intercept, if you remember math 1, all right? So, like I said, now we are dealing with a linear regression or a linear correlation in this case. So this line is also known as the line of regression, okay? This line is known as the line of regression, all right? In other words, it's linear regression. What does this mean? This basically means it is a line that can be drawn between all these scattered points, as I was talking about earlier, that will relate all these points, or will be the average line that is going through all of these points, basically going through the middle of all these points, scattered points. This is what the line of regression is. And like I said, linear, meaning straight line, معناته we're going to be applying the straight line equation, which is y is equal to mx plus b. For the regression, linear regression, it is y is equal to the slope, they usually call it a1 times x, plus the b, they usually call it a0, or the intercept here, basically. All right, so a1 is simply nothing but the slope. Okay, you guys can keep it in m form if it's easier for you guys, but this is just the standard notation of how they write it down. For a1 is the slope, and this is the y-intercept. Same exact equation, okay? So this is the equation for this line, this middle line over here. This is the equation for it. And they usually put y hat for the line of regression, because this is an estimated line of regression equation. All right. Again, this is just all notation. What you guys need to know is that it is following the straight line equation. And how can we find the slope and a0? There are some long and very annoying equations for them, but if you found covariance, it will be much easier, and I'll show you how in a bit. But let's first look at the equation if you want to get it directly from a table. So it is going to be the summation of x minus x bar into x minus y bar over the summation of x minus x bar squared. All right. And a0 is very simple. A0 is always just y bar minus a1 x bar, okay? Obviously, there are a lot of different equations you can apply, not just these two. There are other equations that are using x and y directly without using x bar, but I am not going to use any of those. The way I will solve this is, let me make this smaller. All right, so this is one of the equations if you want to find it directly. So you're going to find x minus x bar in the table, then x minus y bar in the table, and then x minus x bar, you're going to square it from the table. All right, but let's say we have our covariance already. All right, so a1 is going to be equal to the covariance of xy divided by the variance of x, or in other words, covariance of xy divided by sigma x squared. This is how you find the slope of your equation, all right? Remember, this a1 is simply just the slope. Let me just clarify that. So this is a1, which is the slope, and this is a0, which is the y-intercept. Okay? So simply, that's all you need to find your equation of a line. You just need to find your covariance, and you divide it by the variance. And that's it. And that's your answer. And remember, it's going to be the variance of x. In other words, it's the standard deviation squared. Because remember, sigma x is equal to standard deviation of x. All right? So it's the standard deviation squared, or in other words, the variance. All right? So that's it. This is how you would apply it. You just plug in your values. We found your covariance, and then you find your variance, which is already found. If you look at the last step, we already found our sigma x. All you're going to have to do is square this number, or just remove the square root from here. Yani we're just going to square this number. Yani let's apply it for our, actually, let's apply it for our equation. So a1 is going to be equal to, our covariance was 120.833. 0.833 divided by our variance for x. So in other words, we are gonna have, this is our standard deviation, which is 12.5 squared. 12.5 squared sigma x squared. And that's it. This is how you find a1. So a1 is going to be 120.833 divided by 12.5 squared, which is 0.77333, and this is our a1 value, or our slope. For b, or sorry, for a0 is equal to y bar, which is the average y bar, which we found earlier. Y bar, if you remember, it's this one, 82.5. So 82.5 minus a1, which is the value we just got, 0.77333, times the x bar, which is the average of the that we got from the very beginning for x, which is 163.75. So 163.75. So a0 is simply, we just put all of this in the calculator. 82.5. So it is minus 44.133. All right. And this, now, if we want to write our line of regression formula, so line of regression, y is equal to a1, which is 0.77333x minus 44.133, because we got a negative value for our y-intercept. And this is basically the equation of this line over here that I estimated. If we draw it now to scale, let's try to draw it a bit to scale. All right, this is x, this is y. Let's say this is 20, 40, 60, 80, 100. Actually, let's make it 10, 20, 30, 40. So 10, 20, 30, 40, 50, all of that, okay? And this is, what were our values? Again, let's do the same. So 10, 20, 30, 40, blah, 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 until the end, all right? So if we look at our x and y values that we got, and we want to plot them, right? This is the x and y values we had earlier. Let's try to be a bit more precise now. So this is 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150s over here. So this is our 150. And 10, 20, 30, 40, 50, 60. This is our 60. So it is going to be over here. This is our first point. 165 is going to be, this is 160. So 165 is going to be somewhere in the middle over here. And it is at 80, which is here. So this is going to be somewhere along here, right? This is 165. And then 160 is going to be here. This is 160, 160. And we have a value of 100, 100. So this was 80. This is going to be 100. And this is going to be 90. So at 100, we have 160. So it's somewhere like that. And the last point, which is 180. So this is 180 over here. 180 is at 90. So it is something like this if we want to be a bit more accurate. So now let us plot the actual line of regression. So how do we plot a line of regression? Very simply, we can take two values. First, we have the y-intercept as a negative value over here. It's a negative value. So we know it's intercepts the y at somewhere at the bottom here. All right. Actually, I should keep this in black. All right. So minus 44.13 is going to be somewhere here. So this is 10, 20, 30, 40. So minus 44.3, let's say minus 45. It is somewhere over here. All right. Minus 44.133. Again, y-intercept means it is intercepting the y-axis. Okay. And now we need another value. Let's find our x-intercept. So when y is equal to 0, when y is equal to 0, 44.133 divided by 0.77333. We get, so again, this is all math 1. I don't know if you guys will ever need to do plotting or whatever, but I am just doing this to show you guys what it will look like, all right? So x-intercept is equal to 57.07, doesn't matter. So 30, 40, 50, 60, 57 is going to be somewhere over here, all right? So now if I want to draw a line between these two points, this is what my line of regression will look like, all right? So if you notice, it is going somewhere in between these values. So this is the whole idea, all right? This was 57.07. Yani it's almost going right in the middle, just as I drew it here, all right? It's the same kind of idea, but this is way more accurate. And this is how it would look like at the end for the example that I gave you guys. Any questions about line of regression? A quick recap. Again, all we are doing is finding our A1. A line of regression is a straight line, all right? Because we're talking about linear regression. So it is going to follow the straight line equation, y equal mx plus b. Y is equal to A1 plus A0 instead of mx plus b in this case, because it's just the notation. You guys can call it m and b. It is the same thing. But usually they call it A1 for the slope and A0 for the y-intercept. A1, there is multiple equations. There's another equation also other than this if you guys want to use it to find A1. But if you already have found the covariance, you can simply just find the variance, which is just the square, the standard deviation squared. And you divide them by each other to find your slope. And once you find your slope, you can find the intercept by finding y bar, which we already found earlier, subtracting a1 times x, which bar, which is the slope that we found from earlier, times the, again, average that or mean that we found from earlier. Then we have a value for a1 and a0. Then you can basically plot the diagram. The last point is, now Remember, what were we talking about? This was height and this was weight. Okay? What was the point of all of this? So we are trying to find the relation between x and y. So الحين أنا بقول لكم يعني for example, what if there was a person of height 170? Okay? So let's say a person of height 170. Can you estimate the weight of this person؟ يعني الحين واحد طوله 170 تقريبا من الداتا اللي عندنا من الداتا that we obtained كم بيكون الويت ماله. So how do you do that? It's simple. This is why we found this equation. This equation basically gives us an estimate of how much the weight is with respect to the height and vice versa. So remember, our height is x. So with this equation, then we can simply just plug in this number into our x point and find the height or the weight of this person. So it's going to be 0.77333 times 170 minus 444.133. So the weight of this person is going to be 0.77333 times 170 minus 44.133 is going to be estimated. Remember, this is an estimation of 87.33 kilos or whatever. All right. This is the estimated weight. And this is how you are using statistics to determine, to analyze data. This is how the whole point of analyzing data. Yani it is trying to find a scatter, trying to find the relation between them. All right. And then once you find the relation, you want to develop a relation into mathematical relation, in this case for a linear regression by using the equation of a straight line. Once you develop the straight line, you can now have a relationship for any point, any height, and any weight, depending on the line equation that you got. And also, you know how accurate this value is or these variables is based on the correlation that we have found earlier. Knowing that this is moderately correlating, we know that there is a relationship, but it's not that accurate. So we know that you could say percentage of accuracy is around like 56% accurate for the data based on what we have gathered. This is the whole idea of doing all of this. All right. Remember that this is just based on data. يعني in reality, when we're talking about height and weight, it is completely different because people that go to the gym might have a shorter height but a much bigger weight because they have a lot of gains, or some people might be very tall but very skinny because there isn't an actual there is a relationship between height and weight, but it isn't a very يعني concrete one. يعني مو شيء 100% صح. واحد عادي يكون قصير ومتين، او واحد عادي يكون طويل ومتين، واحد عادي يكون قصير وضعيف وطويل وضعيف. It doesn't really have a specific relation. It depends on a lot of factors. The idea here is finding it through mathematical relationships, through data, just through the data given. We only have this data for the specific sample that we took, and we are assuming. يعني for example, let's say this is the height and weight from X people from this gym. Yani we took 20 people from this specific gym to take these values for. So we are getting the data for people at this gym, not the population of the world, basically, or something. We're taking the sample data from the gym itself. Let's take a 10 minutes break and we'll solve a few questions. If you have any questions, feel free to ask. All right, let's make it a 5-minute break. So we'll be back at 11:25. All right. If you have any questions, feel free to ask. I'll be around. Are you guys actually understanding what I'm saying? I just want to make sure you guys are still with me and it is clear. يعني مو بوايد ضايعين. Is it somewhat clear? Is it understandable? All right. I'm glad. We'll do some questions after this so you guys can see how you would look at a problem. So just a quick point before we start solving. Remember our R, the correlation coefficient. This is basically how it looks like. So when you have R is equal to 1, where it is perfect positive correlation, basically all the points are laying on the line. When you have it between 0.8 and 1, that's a very strong positive correlation. معناتها there is an actual good relationship. And then strong positive is between 0.6 and 0.79. Moderate, meaning it is average, between 0.4 and 0.59. A weak correlation means it's 0.2 and 0.39. And then very weak is from 0 to 0.19. And then 0 is basically when you have no correlation. It's the same thing for the negative values, but you just put the negative value in between. So if it's between negative 0.8 or negative 1 and negative 0.8, it's very strong, and so on and so forth. All right. So this is how you would understand if the relationship is a strong one or not. All right, from these values. Let's look at some questions. So here the question says, the data below refers to the monthly sales in thousands of BD, all right, of ice cream and the average temperature for a period of 6 months, all right? So they took this sample, so compute the sample covariance. So we're talking about sample now, all right? So they took this sample with these values for temperature, which they called it X, and these sales in thousands of BDs for the ice cream Y. So they're trying to find the relationship between the temperature. We need to find out if there's a relationship or a correlation between temperature and ice cream sales. All right. So the temperature of the ice cream and the how much sales or how much money they're making off when it's at these temperatures. So the first part says compute the sample covariance and interpret the results. So again, the first thing you are going to be doing is you're going to be making your table, right? So let me make this a bit shorter like this and longer over here. So we can make our table on the side. So first thing we need to find, remember the equation for covariance, we are talking about sample, remember? So sample, meaning we're using n minus 1, all right? This is the difference between sample and population. We're going to look at the population one after this. So what is our first step? Our first step is finding our sigma x and sigma y. In other words, we are just going to be adding up all these values. So if you add 15 plus 12 plus 10 plus 25 plus 22 plus 20, you get 104. Ice cream sales, when you add them all up, you're going to get 1,710. Why are we finding this? So we can find our average. Okay. So our average is sigma or x bar and y bar. Okay. And if you remember, x bar is simply just sigma x over n, and y bar is equal to sigma y over n. Remember, mean is always going to be over n. Okay, it's always over the number. It's not n minus 1. Only for the mean, all right? For the mean, there doesn't matter if it's population or sample. It is always going to be the number of values you have. You're going to add up all of them divided by the number of values that you have, all right? So for x bar, it is going to be 104. First, what is our n? Our n is, we have 1, 2, 3, 4, 5, and 6. So our n value, our n is equal to 6. Okay? So this is going to be 104 divided by 6, which is equal to, actually, let me write it down so that we have space here. So this is going to be equal to 104 over 6, and y bar is going to be equal to 1710 over 6. Okay? We get a value of 17.33 for the x bar, and y bar is going to be 285. All right, this is our first step. Now Now that we found our x bar and y bar, remember covariance, the equation for it, so covariance of x, y is equal to the summation of x minus x bar, y minus y bar, divided by, for sample, n minus 1. Okay, so what do we need? We need x minus x bar, we need y minus y bar, and then we're going to have to multiply them into each other. So x minus x bar for the first one, and then we have y minus y bar for the second one, and then we're going to be multiplying them into each other, so it's x minus x bar times y minus y bar, right? So again, x minus x bar is simply, for the first one, we're going to be subtracting 15 minus our x bar, which is 17.33. All right, this is what we are going to be, this is what we're going to be doing for all of them. Okay, so this, I'm just going to keep it on the side over here. So 15 minus 17.33. Let me make it a bit smaller and just keep it on the side here. So 15 minus 17.33 for the first one, which will give us negative 7/3. All right. I like to keep things in fraction if I can, because it gives me more accurate results when I'm calculating later on. The next value is going to be minus 16/3, which is 12 minus 17.33. And you will do the exact same thing for all the rest. So the next value is 10. So this was 12 minus 17.33, 10 minus 17.33, which is going to give us negative 22/3. Then you're going to do 25 minus 17.33, then this minus 17.33, and minus 17.33. We're going to get 23/3, 14/3, and 8/3. All right. Again, you guys can keep it in decimal form if it's easier for you. I like to keep it in fractions if they're basic small fractions, because it just makes the calculation a bit more accurate. That's the only idea. All right. Same thing now we're going to be doing for y. So this is going to be 320 minus 285. 320 minus 285 is going to give us 35. Then minus 125, which is this minus 285. And we're going to be doing the same for the rest. And it's going to give us minus 125, minus 55, 15, 75, and 340 minus 285, which is 55. Okay. And now we are going to be multiplying this number and this number. All right. So there's going to be multiplication in between both to get the value over here, which is going to be minus 245 divided by 3, 2000 divided by 3, 1210/3. Again, I keep it in fraction just for accuracy. You guys can keep it in decimal if you like. 115, 350, 440/3. And now we need to find the sum over here. So we're basically going to be adding all these values together. So we're going to be doing this plus this plus this plus this plus this plus this. And remember, signs are very important. So when you're multiplying, make sure you do not forget the sign. So here we had a negative value and a positive value. So the answer is going to be negative. Here we had negative times negative, so the answer became positive. Negative and negative, answer became positive, and the rest are just all positive, so it became positive. All right. So just make sure you do not mess up with the signs because they're very important. Once you add up all of these, you are going to get an answer of 1,600. There we go. So it's 1,600. All right. When you add up all of these, your final answer is going to be 1,600. All right. And that's it. And now you can apply and plug in into the equation. So this is the value of the numerator, the sum of x minus x bar times y minus y bar, which is what we have found here. So this is going to be equal to 1,600 divided by n minus 1. Our n is 6 minus 1, which is equal to 320. So this was our first step. This was part 1. All right, part A. We are trying to find the covariance. Let's look at the next part of the question. So part A is done. We're done with this. Compute. So it says interpret the results. What is meant by that? So if we look at here, what does this mean? We have a positive covariance. So we know that the value is basically a positive relationship. So we can say this is a positive relationship. In other words, we know that as x increases, y is also going to be increasing. And we can see that also from the values here. So when we had 15, it was a high number. 12, we had a high number. 10, we had a somewhat lower number, yani from 15. So basically, the x and y values are increasing together. If x is increasing, y is increasing. All right? So this is what is meant by interpreting the results. Understanding that this is a positive value. This is plus 320, so it is a positive relationship. Now part B says compute the correlation coefficient and interpret the results. Round your answers into 2 decimal places. So if you remember, now that we have found the covariance, all we need to do is just apply R is equal to covariance of xy over the standard deviation of x times the standard deviation of y. And we know that the standard deviation of x is going to be equal to the square root of the summation of x minus x bar squared divided by n minus 1, because we're talking about sample. The same thing, sigma y is the summation of y minus y bar squared, y minus y bar squared divided by n minus 1, all under square root. All right? So we can find our sigma x and sigma y values now, but before that, we need to compute x minus x bar squared and y minus y bar squared. So we come back here, x minus x bar squared and y minus y bar squared. All right? All we have to do is just take this value and square it. So you're going to just take this value and square it. So it's going to be minus 7 over 3 squared. And we're going to do the same for everything else. So minus 16 over 3 squared, minus 22 over 3 squared, 23 over 3 squared, 14 over 3 squared, and 8 over 3 squared. You can leave it like this here. And then in the calculator, you can just start adding them this way. So you don't have to find and then write and find and then write for each one. You can just start adding them up because all we need is the sum of this. So the summation is, so you're going to be taking your calculator and you're going to write minus 7 over 3 squared plus minus 16 over 3 squared. And just make sure you have the parentheses for all of them. And then you're going to get the total value of 175.33. So 175.33. This is going to be your final answer. Or if you want to keep it in fraction to be a bit more accurate, you can. You get 526 over 3. Okay? Again, same thing you're going to do for y. Instead, now we're going to be taking this value over here. So 35 minus 125 and the remaining. So it's going to be 35 squared minus 125 squared minus 55 squared, 15 squared, 75 squared, and 55 squared. Okay? Again, you're just going to find the summation now. And that's going to be 28750. All right? So now that we have found the summation here and the summation here, we can just plug in into these into sigma x and sigma y. So again, just so you guys understand, this value over here is equal to this summation, all of it up here, and the same thing for this value over here, 28750, it is going to be the summation over here. So we could just plug it in to find sigma x. So we know n is 6 minus 1 at the bottom, and at the top it is 526 over 3. So 526 over 3. All right, which is going to give us a value, and then sigma y is equal to n minus 1 is just 6 minus 1, and we found this value for it, which is 28750. All right, 28750. Once you plug these into the calculator, you're going to get a value for your standard deviation. For sigma x, you're going to get 5.92. And for sigma y, you're going to be getting 75.83. All right, and now we can find our R. R is equal to the covariance. All right, the covariance, which is the value that we have found here over here, so 320, divided by sigma x, which is 5.92, and sigma y, which is 75.83, right? Again, where did I get these values? This is my sigma x, all right? This is my sigma y. And this is my covariance that we have found here. All right? And that's it. Plug this into the calculator, you're going to get a value of 0.71. All right? So now the question is also saying interpret the result. And they wanted us to round it into two decimal places. So that's why I have put it up to 2 decimal places. But I'm pretty sure you guys know how to round at this point. And if you notice, if we compare it to this table, so 0.71 is a strong positive correlation because it's between 0.6 and 0.79. So we can say that this is a strong positive correlation. Okay, this is what is meant by interpreting what this result means. And that's it for part B. We are done now with part B. Let's look at part C. Determine the equation of the regression line of number of packaged goods sales Y on fresh produce sales X, assuming a linear relationship. So obviously they're always going to be saying that. So assuming a linear relationship, and they say round off to 5 decimal places, so that can be a bit more accurate. So what we are trying to find is the equation of a line, equation of a linear line. So in other words, we need to find part C, we need to find Y is equal to a1x plus a0, right? Where we know that a1 is equal to the covariance of xy divided by the standard deviation of x squared, and a0 is equal to a0 is equal to y bar minus a1 x bar. And that's it. And you can find your equation very easily. So y bar is a1 times x. A1 is equal to the covariance of xy over sigma x squared. Remember, this covariance is 320, and sigma x is 5.92 that we have found earlier. So this is 5.92 over here for sigma x, and covariance is the 320 that we found over here. So A1 is simply just equal to 320 divided by 320 divided by sigma x, which is 5.92, all squared. Okay, that's it. And you have found your A1 value very easily, which will be 9.12548. All right. And now if you want to find A0, A0 is equal to y bar. Y bar we have found from the table at the very beginning, which is 285. So 285 minus A1. All right, so we're looking at this equation over here. Minus A1, which is just 9.12548 that we have found earlier. Okay, this is our A1, right? Times X bar, which also again we found from the table from the very beginning, which is 17.33. And we have found our A0. So A0, we just put this all in the calculator and we're going to get 126.82533. Again, if you get slightly different answers from what you get from the solution, it's fine because you know there is a lot of round off error. Yani, some people might have put 5.92 here, some people might have put in 5.92376, whatever. So it depends on how you are finding your values. As long as your first 3, 4 values are similar, just know that you are doing the correct job. And now we can just put it back into this equation, our y bar equation, to find the line. So y bar, or y hat, is equal to A1, which is 9.12548, plus times x, actually, times x, plus your A0, which is 126.82533. Again, this part, this is simply just your A0. All right, this is just A0. All right, and so let me just actually write on top of it. This is A0, and this is your A1. Okay, this is just the value from A1 that we have found early on over here. Okay, that's it. And now you have your line for regression. So that's all the question wanted, to find it and rounding off our numbers. And now part D. So part D is now telling us to estimate. Once you see estimation, estimate. Once you see the estimation, just know that you're going to have to plug in a value into your equation. So the package goods sale, if fresh produce sale is at 7. So in other words, this is your x value, x equal 7, and they want us to round off to 1 decimal place. So when x equals 7, what is y? This is basically what they're asking here. So part D is saying that x is equal to 7. What will be y? So how do you do that? You just plug it in into your line of regression formula. So y is going to be equal to 9.12548 times 7 plus 126.82533. Put this all into the calculator and you're going to get that this is equal to 190.697 rounded off to 1 decimal, 191. Or actually it's going to be 190 point, is it 1 decimal place? Yeah, so it's going to be 190.7. Okay, to 1 decimal place. Is it clear? عادي نحل بالآلة الحاسبة مود 3 بعدين AC بعدين shift 1. You can. I'm not gonna say you cannot, but as long as you know what you're doing. Then sometimes you can get confused when you're using the calculator. Sometimes you put one wrong value. I usually don't advise using calculator unless you're very comfortable with it. There is a lot of ways you can do it using the calculator طبعا. But I do not recommend it if you are not comfortable with using your calculator. But you're right, you can use the calculator to solve it much faster. You're right. Any other questions? The remaining questions are almost exactly the same, exact same techniques as well. They want you to find, in this case, population covariance. So I'm not going to solve it fully. I'm just going to show you the steps. All right. So here, if you notice, first thing, they didn't give you your x and y values. You can just say what your x and what your y value is. Yani I'm just going to name the first one as x and the second one as y. Actually, if you notice even here, and question C, because they have to determine what your line of regression is. You need to know which is the Y and which is the X. So here they're saying income from petrol sales is going to be your Y. So that means this is going to be your Y. All right. And on cars sold is X. So this is going to be your X. This is how you can make sure. But it's going to be always clear in the question what is your X and what is your Y. Okay. And in this case, if you notice, we are given a horizontal table. Don't let that confuse you. You guys can do the exact same thing with the horizontal one. And keep in mind in this question, it is asking for population. So we're not going to be using n, not n minus 1. So if we just look at how this will be solved very quickly. So for covariance, what you're going to be doing is, instead of doing it horizontally, you could invert this. يعني تقدرون تكتبون this in a table up to down if it makes it easier. But if you want, you could just do your table in this way. So you're going to write here x minus x bar, y minus y bar, x minus x bar times y minus y bar. All right. Again, it's all about preference on how you want to solve. It's the exact same thing. The methods are always exactly the same. You could just write the table from up to down if it makes it easier for you guys, as long as you don't mess up the values. So, and then you just fill out all of these over here. And your summation is going to be on the right side instead of the left now. So you're going to have the sum over here. So you're going to have the sum of x is equal to, and then you're going to find your x bar over here. Same thing, you're going to find your sum of y over here, and then you're going to have your y bar. All right. Yeah, that's pretty much it. Remember that the first one is x, second one is y. And then you're going to do your calculations for x minus x bar, fill out this table. Once you fill out this table, you're going to find your sigma over here, the summation of these. All right. And then you're going to apply your covariance equation, xy, which is equal to the summation of x minus x bar times y minus y bar, all over. In this case, because we're talking about population, it's just n at the bottom. Okay. Again, this is because and this is because this is population, not sample. All right. Once you find your covariance, then from there it's easy. So 1, this will be your first thing, covariance. Second, it is going to be your regression R, which is equal to covariance divided by sigma x times sigma y. And you know that your standard deviation is going to be x minus, all right, it's going to be x minus x bar squared over, in this case now, because we're talking about population, all right, so this is because of population, it's just n, not n minus 1, and sigma y is equal to y minus y bar squared over n, again, n because this is population, all right? Now you find, how do you find these? You go back to your table and you're going to insert 2 more lines at the bottom. You're going to have your x minus x bar squared. And then you're going to have your y minus y bar squared. All right. Let me just fix this table a bit. So once you do that, again, you can do it in the calculator in whichever way you want. I prefer just adding them up directly in the calculator, as in يعني, you're just gonna put whatever value. Let's say this is 7. Okay, you're gonna put 7 squared like this over here, and then you're just gonna keep doing the same for the rest, and then adding them directly up in the calculator so you can save some time during the exam. Yeah, and that's pretty much it. And then once you do that, the reason you're adding them up is because you are trying to find the sum at the end of the day. So this is, you're going to find the sum and the sum over here for your y bar as well. I'm gonna remove this so that there's no confusion later on. Once you find your sums, oh yeah, of course there's a summation point here. This is summation. This is summation. Once you find your sum, you're going to be plugging it into this, and then you're going to be plugging in sigma x here, sigma y over here, and the value of your covariance up here. Okay, so the value you're going to get from covariance, you're going to be putting it here. The value you are getting from your sigma x, you're going to be putting here, and the value that you're getting from your sigma y, you're going to be putting here. All right. Once you're done with that, third is line of regression or regression line, which is y is equal to mx plus b, or in this case, a1 plus x plus a0. All right. This is your slope. Keep that in mind. And this is your intercept, your y-intercept. Okay. A1 is equal to, since we have our covariance already, covariance xy divided by standard deviation squared, or in other words, the variance, so sigma x squared. And then a0 is simply just y average minus, is it minus or plus? I think it was plus, no, minus, all right, minus x, minus a1 x bar, okay? So minus a1 x bar. And that's it. And then you're just going to be applying this equation, and then you're going to have, you're going to plug in your values back into a1 over here and into a0 over here. And then step 4, or the fourth question, would be an estimation. Estimate. All you're going to do is you're going to have an x value. So they're going to say x is equal to a specific number. In this question, it was 27. Let me just make sure of something. Yep, 27. Okay, so just one extra point here. So here your X value is cars sold. I don't know if they're going to test you on this. And here they're asking for cars sold again. All right, so estimate the income from petrol sales if cars sold is 27. So now we know that this is our X value. All right, so X equal 27. I'm not sure if they're going to test you on this, but make sure that what they're asking for is for the X value. If they're talking about the income, for example, let's say estimate the number of cars sold for an income of this much, then you know that your Y value is going to be that number, uh, not your X value. All right, but I'm not sure if they're going to test you on this. Just in case, make sure you are reading the question and relate what you are talking about. No, when you're talking about cars sold, it's going to be X. If you're talking about income, you're talking about Y. All right, in this case, it is just simply X. So X is equal to 27. And you're going to be plugging it into the Y equation that we have determined, which is A1 times 27, which is our X value, plus A0. And that's your estimation of Y. Okay, that's it for today. I wish you guys all the best on your exam. We're going to be having one more session, inshallah. I still